This glider collisions lab is not just a great opportunity to study collisions, momentum, and energy conservation, but also to practice a very transferable skill, and that is harnessing the power of spreadsheets. So only a few of you have taken advantage of that. Basically, if you've taken physics before, I noticed that you are doing it. So Aiden, Di, Michael, Taylor, and Will, they've basically done what I'm about to show you. But I like to show you how to use the power of spreadsheets to do some math for you, and then also to therefore reduce errors. So I'm going to go to row 12 here, okay? And I've picked a trial that nobody else picked. I've already calculated my incoming velocities, okay? Notice here that I didn't just type the number though. If you look up in the corner, here's the formula, and basically you can see how I derived it, right? So it's a little bit of an additional information. I let the glider on the left go 5 centimeters, and that took 0.6833 seconds. So you can kind of see how I got that, right? Whereas if I go to some of your others here, I just have a value. Obviously, if it's 0, that's no big deal, but I don't really know how you got that. So you don't have to do it that way, but it's nice to show a little bit of additional information. But here's where we really start to harness the power of spreadsheet. So we know that momentum is mass times velocity. So what I'm going to do here is I'm going to type equals, and I'm going to take the mass of the left glider, right, which I have typed up here, and I'm just going to click on that, right, because I've put the value in E2. So notice it's placed E2 down here. Now I'm going to go times, right, so M times VI, which is right here. And then I just hit enter, and it calculates it for me. And then I can simply come across and do the same things. Right now I'm going to the right glider, so that is this 300 gram one times its initial velocity, and enter. Just a note here about calculation. I noticed that I've made an error that many others of you have made as well, and that is we have not paid attention to direction. Okay, remember that momentum is a vector, and so we need to pay attention to direction. That means all these velocities here, right, moving from the left to the right, those would be positive, and then these would be negative velocities, okay, unless they're 0. So all of you here have failed to put the negative sign, including me, except for Anton and Adil. They have noticed that. So I'm going to come in here and type a negative to make sure I get that negative velocity, and therefore notice this changed automatically, right? Negative momentum. So once you have these values, right, now you can begin to populate successive cells in the same manner, right? This would just be adding these two momenta together. So I'm just clicking on the cells, hitting enter, and you can see how that works very easily, right? Reduces errors, lets the spreadsheet do the heavy lifting for you. So if you have not done this already, I'd like you to go back through your row and calculate each of the cells in the manner that I just showed you, okay? For this to work, you have to be referencing the cell that is a number only. So I'm just going to point out what I did up here, right? Here is the value of the mass of the left glider, and then I put the units in a separate cell, right? That way, when the spreadsheet looks to E2, it sees only the number. If I would have typed kilogram in there, it would not have recognized it as a number, and it would not have been able to do the mathematical operation that you asked it to. One more note, I did decide to do the very last calculation a little bit differently. Okay, so instead of PI over PF, I'd like to do PF over PI, right? Final over initial. So I'm going to flip that around, okay? And I'd like you to do the same, right, in your calculation. Do the PF over PI, and here I've changed this one already, right? Final over initial. That way, if we have conservation, right, we would have a ratio of 1, and if we don't have conservation, then we would have a ratio of less than 1. All right, good luck. Email me if you have questions.